Good afternoon, this is Schweitzer, and we're going to do a couple of problems here involving practicing writing out solubility reactions and seeing if you are on track for this and getting ready for our quiz. Alright, so again, this is just looking at doing some of the manual labor for this. Alright, one thing is indicated here that different combinations of ions have different solubilities. So just because a sodium and a phosphate soluble doesn't mean the magnesium and the phosphate wouldn't be. So first thing we do here, again on paper wise, I like to know the charge of these. This is a reaction where the charges are not going to change. This is a plus 1 minus 3 plus 2 minus 1. Okay, now this cation, we're going to attempt to put it with this anion. So it's going to be sodium, which is again plus 1, and a chlorine, which is a minus 1. Now that 2 there is because of the charge balancing here. I don't want to bring that along. Recharge balance on this side. And then I have magnesium and phosphate. That's going to be magnesium, which is a 2 plus, and then I have the phosphate, PO4, which is a minus 3. Charge balance, the 3 will go right there, and then the 2 goes here. And that's just, we're all just on paper. This is not in a beaker. It's in a beaker, but this is on paper, so keep that in mind. Alright, so next thing I want to know is, do we have any new products? So I'm looking for either water. It's the only place we'd have water is liquid. But I want to know, am I solid or am I aqueous? Alright, so with that, let's go to our solubility chart. Okay, so this is my solubility chart right here. And a couple of things I'll point out here is that, and you have this in your workbook, okay? Aqueous, it means is soluble, and insoluble is going to be solid. First thing I do is I go to my quick check. If I have any of these three, I'm always aqueous. Okay, and I don't have a pen here to write on. I would write right on AQ for here. All right, and then next, so do I have one of those? Well, here's a quick check, and either one of them, doesn't matter, it's now AQ. And this guy does not have a quick check. So the chart, if there's no quick check, then I go to the chart again. Typically works off the anion, the phosphate. So we look for phosphate here. Here's a phosphate. Phosphates generally are insoluble, forming solids. These are the exceptions, which are just our quick checks. Okay, so this guy is going to be, if the cation is one of these three, so if the cation, this guy right here, is a sodium, potassium, or ammonium, then this would be AQ. But it's not. So it's not one of the exceptions. This thing generally is insoluble, and there you go. If I have two aqueuses, I'm a no reaction. Okay? Two solids, we need something new forming. We'll see why as we start drawing them out. And this thing is done. Balancing wise, 2 phosphates, 2 phosphates, 6 sodiums, 6 sodiums, 6 chlorines, and we'll need a 3 right here. Okay? Next one. Alright, so I have plus 1 minus 1, plus 1 minus 1. Alright? Draw these out. This guy with this guy is going to be AgNO3, and I have CuNO3, and it's a plus 2, by the way, because that 2 is right there. So it's going to be Cu parentheses NO3 parentheses 2. Why is that like that? Because I got a plus 1, plus 2, and a minus 1. Plus 1, minus 1. Charge balanced. Go to our quick checks. I got a nitrate here and a nitrate here, which both of those are quick checks right here. Nitrate. Anything in nitrate would be aqueous. So I'm going to get an aqueous right here, and I'm going to get an aqueous right here. Both aqueuses means no new item is formed, and this would be a no reaction. You will also note that really the reactants haven't changed from the products. Okay, and the order you rate them doesn't matter. Okay, all right. Next one, I have silver plus 1, nitrate minus 1. ammonium plus 1, sulfate minus 2. That's why that 2 is there. The 4 is part of ammonium. Rewrite your potential new products. I got ammonium, NH, 4, and then nitrate, NO3. This is a plus 1, minus 1. And then I have silver sulfate, AgSO4. This is going to be a plus 1 minus 2. 2 goes right here. 1 is right here. Alright, quick check. Now, sodium, potassium, ammonium, nitrate. Alright, we got any of those? Well, right there. If they both are, doesn't matter. This is now a key, which means it's not going to form a solid. And then here, okay, look for sulfate. Okay, the sulfate is located right there. Sulfates generally are soluble, form aqueous, but do we have an exception here? Silver. So silver is one of our exceptions. So normally sulfates would dissolve nicely, but silver sulfate does not. That would be a solid. Once again, balance it. 2 silvers, 2 silvers, 2 nitrates, 2 nitrates, 2 ammoniums, 2 ammoniums, balanced. All right. Let's jump down to now. Well, this one right here. Let's just do the number 4 here. So silver chromate, Ag. So I'm going to start jumping ahead a little here. CrO4 plus 1 minus 2. So a 2 goes there, and then plus potassium nitrate. So I'm going to start going a little bit faster here. Quick checks again are above here. Actually, I had them up top here. Didn't realize that. All right, right there. These are my quick checks. So this is going to be aqueous. Okay, now I got to go to chromate. Now chromate's not on the list, so you can look it up, but I'm going to just go solid for chromate. It's not on our sheet. I don't believe. All right. So we got 4 of them done there. Let's go to this lower one here. All right. So how does this work? Well, we got to translate this thing. So I'm going to put it right here. All right. So we have aluminum nitrate, parentheses, now NO3. So plus 3 minus 1. That's why the 3 is there. That's why the parentheses are there. Plus sodium, NaPO4 phosphate. Again, you might need your ion sheet here, and the 3 goes there. All right, yields. Now again, this is a plus 1 minus 3. Okay, so let's charge it out here. This aluminum is going to go with the phosphate, PO4. Now you notice here, this is a plus 3 and a minus 3. So it's balanced. It's good to go. Plus NaNO3. NaNO3. Now, a charge balancing error is going to cause you issues. Regardless, if you balance this thing, you're going to have so many problems if you don't charge balance it correctly. It's just not going to work. All right, now I've got to check solubilities. Quick check right here. This is aqueous. This phosphate. Let's go to phosphate. So phosphates are generally insoluble, and we don't have an exception. So this is going to be a solid. Okay, and then you can balance. I'll let you balance on your own. Let's do 7 quick here as well. 7's a unique one. We have plus 1, minus 1, plus 1, minus 1. Okay, HOH go together, forming HOH, and then we have NaCl. NaCl. All right. HOH happens to be water, and that's going to form our only liquid. And this guy, because water's liquid. Okay, so this guy got a quick check right here. Aqueous. That's a very soluble substance. Table salt is very soluble. And therefore, we do have a reaction. Okay, a liquid is a product of water is a good product. This one here, okay, again, just start like any other one. Plus 3 minus 2 plus 1 minus 1. I'm not going to finish this one, but you can write out your own products. Okay? Got to get a couple more try and see how it's working. Okay? Thank you very much.